Alright, so here's where we left off. I just added a slide that said left off here. And what I'm going to do, I'll go up and I'll actually make it a slideshow just as if you were watching it, in class. So the first thing, we went through the nitrogen group. There's 5 electrons in the outermost ring. So those 5 electrons correspond to the group that it's in, 15. Remember, we get rid of the tens position and we just have the 5. So these elements like to form covalent bonds with other nonmetals. So things like nitrogen and oxygen will bond together. Things like nitrogen and carbon, or any other nonmetal basically, will like to bond with nitrogen. Or anyone in the nitrogen group, I should say. The primary use of nitrogen is it's used in fertilizers. So whether you make, the all-natural fertilizer using manure, or you actually make a fertilizer, in a factory, both of them contain nitrogen. So plants need nitrogen in order to actually grow and be nice, big plants. Phosphorus has 3 different allotropes. So remember, our allotropes just mean that phosphorus can join together and make different kinds of structures. So phosphorus is also used in fertilizers, and it's also in match heads, so matchsticks. So being that phosphorus is in fertilizers, and it's also in match heads, yes, fertilizers are very flammable. They will catch on fire and they will burn. Same thing if we had a nitrogen-based fertilizer. That would also be set on fire and burn as well. Antimony, so if we continue going down the chart, antimony is a metalloid. And bismuth is a metal. What bismuth is used for, it's kind of unique. It's used to lower the melting points of metal. And so we find it a lot in automatic fire sprinkler heads. So what that means is if we have a fire and bismuth is part of the metal that makes up the automatic sprinkler heads, when it gets too hot in the room or the flames start to get too high, that metal will actually melt. When it melts, that's what makes the automatic sprinkler heads actually set themselves off. So bismuth is a very useful metal that, are used very much in a lot of those automatic fire sprinkler heads. So our next group, moving across, is the oxygen group. These are group 16 elements. Oxygen itself is where the name comes from. It's a nonmetal. We find it in the air, and this was one of our diatomic molecules, so we find it as O2. So the oxygen that you breathe in is actually in the form of O2. Moving down the group then, we have sulfur. Sulfur is a nonmetal. It has many allotropic structures, even more than carbon had. We're not mentioning other than the fact that they have many of them. We don't really have to necessarily know what they are like we did with carbon. We just need to know that there's multiple allotropic structures. Sulfur is often used as a pigment color in paint just because it has a very vibrant color. Sulfur by itself is a very, very bright yellow. Think of a very bright yellow, and that's what your sulfur structure is actually going to look like. So it's useful in making very vibrant paint colors. So moving down, selenium is a nonmetal. It's needed in our body, but it can be toxic if we actually take too much. So a lot of multivitamins, a lot of your foods will have trace amounts of selenium in them because we do need them in order to live, but too much of a good thing could be bad for us. The last two, tellurium and polonium, those are metalloids. They don't have any real super use that's worth mentioning. We just need to know that they are 2 metalloids. All right, synthetic elements. So when we started this lecture, we said that, there are some elements that are man-made and some that are occurring natural. And we posed the question, why do we want to actually create elements? So the way that we create them is we do it in a lab, and what they do is they bombard an element with neutrons. So meaning that they take an element that is naturally occurring and basically just shoot neutron bullets at it, trying to get it to change its atomic structure. So as soon as we can get it to change its atomic structure, it's now become a new element. So one thing that they do, they take uranium, all right, and if they shoot neutrons at it, it actually turns into plutonium. So plutonium is a man-made element. It's on our periodic table. You can actually look. It is there. And that's one that's actually man-made. Another one that they do, they then take the plutonium that they just created, they shoot neutrons at it again, and they make something called americium. So again, a man-made element, but this one actually has uses in your common household smoke alarm. So americium is used in smoke detectors. What happens in your smoke detector is the smoke will interfere with the electrical signal that americium is actually giving off. It gives off charged particles, so it gives off electricity. When the smoke interferes with that signal, it causes your smoke alarm to go off. And if you've ever, cooked anything in your house, burnt toast, you realize that those smoke detectors are very sensitive. But that's good because we want to be able to alert people when a fire occurs. So americium may not have been set out to be used in a smoke detector, but if we wouldn't have tried to create these elements by bombarding them with neutrons, we may have never found this very, very useful metal. All right, next one is called transuranium elements. All this means is that they are the elements that are after or have a higher atomic number than uranium. So these elements are synthetic, they're man-made, they're very unstable, and most of them disintegrate very quickly. Most of them disintegrate within the matter of microseconds. No element thus far, well, other than one, has actually lasted more than a second after it's been created. So elements in this case do have a higher atomic number than uranium. Uranium is 92, so anything higher than that atomic number are ones that are transuranium elements, meaning that those are man-made. These elements really don't belong to any kind of metal, non-metal, or metalloid group. They basically make up their own group. That's why we kind of give them this special name of the transuranium elements. So they don't necessarily fit into either of these groups, and a lot of times they're located at the bottom of the periodic table in your lactinide and your antinide series. All right, so why even make these elements? So we focus on making elements, making synthetic elements. The americium was very useful because it actually made the smoke detectors. But our main goal when trying to make elements is we want to try to understand what actually holds our nucleus together. So what causes the neutrons, the protons, to be held together? We can understand why a proton and an electron might be held together. They're oppositely charged. Positive and negative like to be near each other. But why does a positive and a neutral want to stay in the nucleus together? So scientists set out to understand that phenomena. A lot of our synthetic elements are radioactive, and the radioactivity makes them very useful in medical applications. Previously, most elements made last for microseconds, very, very tiny amounts. Element 114, actually, though, appears to be one of the more stable elements that has been man-made, and they say that it lasts for 30 seconds before actually breaking apart. I know 30 seconds doesn't sound like very long, but in the scheme of synthetic elements, making them, 30 seconds is quite a long time. All right, so that's it then. You just have the reinforcement section 3 homework. You might need the book to help you do it, and um, we just want to make sure we get that done then. So the only other thing is just to go back. I'm just going to scroll back up to the beginning of our notes, and I want to look at those I can statements. So just to see if I can do those things. So again, I can distinguish among metals, nonmetals, and metalloids. So think in your head, can you do that? Describe the nature of allotropes. I can recognize the significance of differences in crystal structures in carbon, and I can understand the importance of synthetic elements. So you want to just sort of, think in your head, can I do all those things? And that is pretty much it for this one.